Hello there, everyone. This is day 4 of chapter 2. We're basically wrapping up most everything today. And what we're going to talk about is a little bit more about the normal distribution. We're going to do a little bit of a review of what we talked about last time, and then show you how you can use either our table from the formula sheet or the calculator to answer some normal distribution questions. So let's go ahead and get started. Share. Okay, so if we take a look here, this is just a review again of what we talked about with the normal distribution. All normal distributions, they're centered at the mean. The mean is referred to as mu, and then we add and subtract 3 standard deviations, and it'll be from the problem. So if we look at a problem like this, it says 2,000 freshmen at a state university took a biology test. Scores were normally distributed with a mean of 70 and a standard deviation of 5. The way to summarize that is n for normal, mu is first, sigma, the standard deviation is second. What we do is we put the mean at the middle. We add 3 standard deviations, so 70 plus 5, 75, 80, 85. We subtract 3 standard deviations, 65, 60, 55. The empirical rule is nice to know. It's not a have to know kind of thing. It's a nice to know. It kind of gives you some perspective of an answer. So if you remember this, great. If you don't, that's fine, because what I'm going to show you is how we can use table A, how we use the calculator to answer this question. So let's take a look at an example question, and we'll kind of work our way through it. So what I want to do is going to look at this first one. Speedmaster 4 automobile gets an average of 22 miles per gallon. The standard deviation is 3 miles. Assume the variable is normally distributed. Find the probability that on any given day, the car will get more than 26 miles to the gallon. Okay, so let's take a look and see how we do that. I've already kind of worked this solution. I'll kind of walk you through it. So what we know from the Speedmaster is it's normally distributed with a mean of 22, standard deviation of 3. So that's how we typically write that. Again, just remember that the 22 is your mean and the 3 is your standard deviation. First order of business, always draw the picture. Always draw the picture in shade. So I put 22 at the middle, plus 3 is 25, plus 3 is 28, plus 3 is 31, subtract 3, 19, 16, 13. And then since the problem actually asks us about more than 26 here, what I did is I put the 26 on here, I shaded it off, and that's the area I'm looking for. This is considered work, so please do that. Always do that when you have a normal distribution problem. There are 2 ways to do it. So let me walk you through the first way, using z-scores and using table A. So what I'm going to do is I'm going to figure out that z-score for that score, that 26 miles per gallon. So if you remember our z-score, it's observation 26 minus mean 22 divided by standard deviation 3. That gives me a z-score of 1.33. Okay, so now let me show you what we have here with table A. This is table A. It's the standard normal probabilities. And what I want to show you is it's always area below. All of these things over here are z-scores. So this value right here is the area under the curve when you have a z-score of negative 3.40. This is negative 3.41. If I jump down here, this is negative 2.44. So this would be a z-score of negative 2.44. Okay. So notice it's always below. This problem actually asks us above. Well, the good thing about the normal curve is that it is symmetric. So what it means is if I am greater than 26, if I'm 1.3 is my z-score here, what I can actually do is I can mirror it on the other side, and I can look at a z-score of negative 1.33. So if we go down here to negative 1.3, trace our finger across to the 3 column, we find out that that probability is 0.0918. Basically, the area under the curve here is a little under 10%, a little above 9%. So what it's saying is the probability of more than 26 miles a gallon is about 0.0918, and we want to go to 4 decimals on that. That's one way. Let me show you the calculator way. You still have to draw the picture, you still have to do the shading, but let me show you how I can do that with the calculator. So go ahead and jump to the calculator. Here's our calculator. What we're going to hit is second, the blue button second, then bars. And we're going to pick the second one, normal CDF. And of course, this one didn't set up the way. I have to update this one. The arguments that you're going to put in for this are going to be your lower bound, your upper bound, and your mean and standard deviation. So let me take a look here again. Let's go back and look at this picture. My lower bound is 26. My upper bound is there is none. So what I do is put in a bunch of 9s to symbolize it goes on forever. My mean is 22 and my standard deviation is 3. So what I'm going to do is I'm going to go back calculator. I'm going to put in 26 as my lower bound. I'm going to put in comma right here. I'm going to put in lots of nines. I'm putting in like 4 nines. Another comma. 22. Another comma. 3. Close that runs off. Hit enter. And what that's going to tell me is that the area under the curve is 0.0912. So look. 0.0912. Probably put in more than 26 miles per gallon is 0.0912. So that's how you use normal CDF to answer a question. Hopefully that helps. I'm going to put up another video that'll actually talk about how we do reverse, how we actually do inverse norm, which is another way we actually use the calculator. So we're going to go ahead and pause. We're going to stop here. I'll put a second video up that'll do inverse norm.